Hello everyone, welcome back to this video series in which we are developing a value at risk model using three quantitative approaches, that is variance covariance method, historical method, and the Monte Carlo method. So in this video, I'll be specifically walking you through the variance covariance method. So in the initial phase of the video, I'll be talking more about the theoretical parts of what is a variance covariance method, what are the steps which are involved in the variance covariance method for calculating value at risk, and then we will be implementing the same steps in the Excel implementation. So let's understand what is a variance covariance method. So the variance covariance method, also known as the delta normal method or parametric method, is a widely used approach for estimating value at risk in financial risk management. So let's define it. So the variance covariance method, which is also known as the delta normal method, or it is also known as the parametric method, is a widely used approach for estimating value at risk in financial risk management. See, whenever we are developing any quantitative model, right, in the field of quant finance or risk management, there are some assumptions that we take before developing, before developing the model. So similarly, when we are trying to build a value at risk model using the variance covariance method, there are certain assumptions that we will be taking. So let me walk you through the assumptions. So there are three assumptions that we will be taking in this method. The first assumption is that the variance covariance method assumes that the returns are normally distributed around the mean of the bell-shaped probability distribution. This is the first assumption. The second assumption is the method assumes that the standard deviation of the assets remain constant over time. And the third assumption is the correlation between the assets remain constant over time. So let's write down these all assumptions before diving into the step-by-step approach of calculating VaR. So the first assumption is the model assumes that the asset returns are normally distributed around the mean of the bell-shaped probability distribution. Probability distribution. The second assumption is this method, the method assumes that the standard deviation of the assets, the standard deviation of the assets remain constant over time. This is the second assumption. And the last assumption is the method assumes that the correlation between the assets, the correlation between the assets remain constant over time. So these are the three assumptions that we take while we build this while they build this value at risk model using the variance covariance method. So now let's understand the steps involved. Okay. So let's understand the steps involved to calculate value at risk using the variance covariance method. Okay. Steps for calculating value at risk using the variance covariance method. Okay. First, See, the first step is, of course, let's say you have a portfolio, right? So in your portfolio, there'll be different stocks. So let's say, you have three stocks. So the first thing is, you have to collect the data, right? So the first step is collect the data. Now, you can gather the data from different websites, okay? So you can gather the data from different website, but the most commonly used website is Yahoo Finance. So just collect the data of your, let's say if you have three stocks in your portfolio, assuming you have Bank of America, Morgan Stanley, and there's some other stock you have, right? JP Morgan, let's say. So you just gather the data from Yahoo Finance website. This is the very first step. Second step is calculate the returns. Calculate the returns. Okay. So how do we calculate the returns is, if you see the mathematical formula, it is returns is equal to price today minus price yesterday. So this is price yesterday divided by price yesterday. So if you see, I can also write this in this way, right? Returns is equal to price today divided by price yesterday minus 1, right? I mean, I have just divided, so price yesterday by price yesterday will be 1. So I can write this also, I can either use this or use this. So it's the same thing. So this is how you calculate the returns, okay? So you might be thinking, Mehul, like why should we, calculate the returns, and why should we not just take the stock price data, right? So there are certain reasons for that. I mean, see the main reasons are, see, I'll give you one simple example. Let's say, yeah, let's say you have a portfolio of $10, and then you have a portfolio of $100, right? So if you say, okay, if there's a $5 increase in this portfolio, so if you see, this will become $15. So if you see, and let's say there's a $5 increase in this, it will become $105, right? But if you are conveying this to someone, you'll say, okay, in my portfolio there was a $5 increase. So, for the viewers to understand how much it, so if you see here, your increase was almost 50%, right? But here the increase was very less, close to 5%, right? So that is why, we always consider this returns. We always try to take in returns, and not just the stock price, because it gives a sense of, uh, it basically does not convey much information, because your stock can go by $5, and that can be a lot in this case, but in this case it is nothing, right? So it's always better to talk in terms of return. This is the first reason, okay, why we should always take return. And the second reason, for which is more from a statistical point of view, is if you see stocks data, right? If you download any stock data, those are like, the stock data is like non-stationary in nature. But what is non-stationary means, it has, the mean is not constant. It is not constant. Similarly, the variance is not constant, and the there's no constant autocorrelation, right? So there's no constant autocorrelation. So this basically means that, okay, so this basically means that this is non-stationary. So when I say non-stationary, it means that mean is not constant, variance is not constant, autocorrelation is not constant. So that is why we take returns. So what happens when we take returns? So when we take returns, right? So we basically convert our non-stationary data into stationary. So when you apply the above formula, right? So your data series now becomes stationary. So, and of whenever you are trying to model, build a model in the world of quantum finance, we always try to take in the return, because we always try to convert the non-stationary series into stationary. This in turn helps you in the modeling phase, because when even if you build a model using the non-stationary data, even though it might have a good fit in the in-sample data, but it will not perform good in the out-of-sample data. So that is why I always feel like, always try to convert your data into stationary. It can be either by converting, by doing this, using this formula. You can also take a log transformation. So this was more from a theoretical perspective, why we don't use a stock data, and why we always convert it into returns. Okay. So let's say, let's deep dive into the third step. So after calculating the return, right? I mean, after you have taken the return, the next step is calculate the portfolio return. Calculate the portfolio return. So let's say you have three stocks in your data, right? Let's say S1, S2, S3. So you first calculate the individual returns R1, R2, R3, right? And let's assume that the weights of S1 is W1, the weights of S2 is W2, the weights of S3 is W3. So what do I mean by weights is, if let's say, you have a $1 million portfolio, right? So what I'm trying to say is, okay, let's say you have this $1 million, right? So I'll say, okay, let's assign 30% of this amount, $1 million to S1. Let's assign 40% of $1 million to S2. And then let's assign 30% of your money into S3. So what I'm essentially saying is, let's give 300,000, let's buy $300,000 of stock one, $400,000 of stock two, and similarly $300,000 of stock three. How this came is nothing but 30% of $1 million. So this will give you this result. So now how to calculate the portfolio return, right? So the return of your portfolio will be W1 R1 plus W2 R2 plus W3 R3. So you are basically multiplying the weights with the returns, right? So as we know, R1, R2, R3 are the returns of individual stocks, like that is S1, S2, and S3. So this is how you calculate the return of your portfolio. But this will give you daily return, right? So now how to calculate the complete return for the whole time period that we have. So just take the average of it. So average of W1 R1 plus W2 R2 plus W3 R3, and this will give you the portfolio return, right? Okay, so once we have gotten the portfolio return, let's try to calculate. The fourth step is try to calculate the standard deviation. Calculate portfolio standard deviation. Okay. So you might be thinking, since like the way we calculate the portfolio return was, W1 R1 plus W2 R2 plus W3 R3, right? So we can also calculate the standard deviation of the portfolio by, W1 SD1, where is standard SD1 is nothing but the standard deviation of stock one, right? And similarly, uh, W2 times SD2, where SD2 is standard deviation of stock two and SD3 is the standard deviation of stock three, right? You might be thinking by this way we can calculate the standard deviation of the portfolio. So most of the freshers do this, and this is the wrong approach. Okay, this is the wrong approach of calculating the standard deviation of the portfolio. You know why? Because even though this formula might give you the approximate standard deviation, but it fails to take into consideration the correlation between the assets, right? So that is why, it's very important that in our formula, when we are calculating the standard deviation of the portfolio, it should always take in consideration the correlation between the assets. So, so you might be thinking, so how can we calculate the standard deviation of the portfolio? Okay. So there's a one approach which is called uh, okay. So let me first write down the formula and let me explain you, how can we calculate it. So the formula that we'll use, right, to calculate the standard deviation of the portfolio is variance is equal to W1 W2, W3, whereas W1, W2, W3 are the weights of stock 1, 2, 3. So we'll multiply this with the covariance matrix. Okay. So I'll talk about covariance matrix, don't worry. And this whole multiplied by the transpose of W1, W2, W3. Transpose of W1, W2, W3. Okay. So this is the formula that we will use to calculate the variance of the portfolio. So standard deviation of our portfolio, as you might have seen in your statistics classes, square root of your variance, right? So this will give you the standard deviation of your portfolio. But see, we know this, right? Similarly, we know this. But what about this, right? You might be thinking. So let's understand what is a covariance matrix. Okay, so let's understand what is a covariance matrix. See, I guess you might have studied back in, your 10th, 11th, 12th grade or maybe less. Like, if let's say you have three stocks, let's say S1, S2, S3, right? Similarly, S1, S2, S3. So the way you will calculate your covariance matrix is covariance of S1, comma S1, right? Similarly, covariance of S1, comma S2. Or let's say, let me first fill it like this. Okay. So this is nothing but covariance of S1, comma S2, covariance of S1, comma S3, right? Similarly, this will be covariance of S2, comma S1, covariance of S2, comma S2, covariance of S2, comma S3. And this will be covariance of S3, comma S1, covariance of S3, comma S2, and this is covariance of S3, comma S3, right? Now, if you see, what is the formula of covariance? Let's say, what is the formula of covariance of S1, comma S2? It is nothing but correlation between stock 1 and 2 times, or let's say multiplied by standard deviation of stock 1 multiplied by standard deviation of stock 2. So in this way, we are capturing, right? If you see, we are capturing the correlation between the stocks. And that is why this covariance matrix really help us to, capture the standard deviation as well as the correlation between the stocks. So now similarly, the formula for covariance of S1, comma S3 is nothing but correlation between stock 1 and 3 multiplied by standard deviation of stock 1 multiplied by standard deviation of stock 3. So you might be thinking, what is the covariance of S1, comma S1, right? So it will be nothing but the correlation between stock 1 times standard deviation of stock 1 times standard deviation of stock 1. So this is, so the correlation with itself is nothing but 1. So if you see row 1, 1, row 2, 2, row 3, 3, right? This all will be 1. The correlation with self is always 1, okay? So, and then, so what will be our formula? 1 times, so this is 1 times sigma 1 square, which is nothing but sigma 1 square, right? So the covariance between S1, comma S1 is sigma 1 square. Similarly, if you see covariance between S2, comma S2 is nothing but correlation between stock 2 times standard deviation of stock 2 times standard deviation of stock 2. This is nothing but 1. So this will become this. Covariance of stock 2, comma stock 2 is this. Similarly, covariance of stock 3, comma stock 3, okay, so stock 3, comma stock 3 will be nothing but sigma 3 square, right? So now let's fill in the covariance matrix, okay? Let's fill in the covariance matrix, which is nothing but stock 1, 2, 3. See, this will not come in the formula, okay? This I'm just writing it just for, a good clarification. So this will be sigma 1 square, this will be sigma 2 square, this will be sigma 3 square. Now this will be row 1, 2, sigma 1, sigma 2. This will be row 1, 3, sigma 1, sigma 3. Similarly, this will be row 2, 2, 1, sigma 2, sigma 1. Uh, Again, row 2, 1 or row 1, 2, it's just the same. So if you want, I can just write in this way. This is nothing but row 1, 2, sigma 1, sigma 2. rho 2, 3, sigma 2, sigma 3, rho 1, 3, sigma 1, sigma 3, rho 2, 3, sigma 2, sigma 3, right? So this is how the this is how the covariance matrix is being created. So now what we'll do is we'll just multiply the weights W1, W2, W3 with our this covariance matrix, and then we'll multiply W1, W2, W3 transpose, right? So this will give the variance of the portfolio. And once we get the variance of the portfolio, how we'll calculate the standard deviation of our portfolios by taking the square root of the variance of the portfolio. Okay. So this was our fourth step of calculating the standard deviation of our portfolio, right? This was our fourth step. Now let's deep dive into our fifth step. So our fifth step is nothing but you need to select a time horizon. See, as I said, determining the time horizon is very important for which you want to calculate your value at risk. So common choices of value at risk of taking the time horizon is 1 day, 1 week, 1 month. Also, if you have not seen my previous video in which I have covered the theoretical concepts of value at risk, I highly suggest you to watch that, because in that I have spoken a lot about what is the time horizon, what is confidence interval, what values do we generally take, what does that signify. So I'll highly recommend you to watch that video. So let's say we take a time horizon of 1 day. Okay. So next step is select your confidence interval. See, confidence interval is why do we select it, right? We always select our confidence interval just to make sure, let's say, okay, so some of the common choices are 95% and 99%, right? So in my last video, I told that what does a 95% confidence interval signify? It signifies that whatever we are getting value at risk number, let's say it's $1 million. Okay, let's assume our value at risk is $1 million, right? So what does this signify? This signifies that I'm 95% confident that my loss will be less than $1 million. Okay, so this I'm confident that my loss will be less than $1 million. But again, there's a 5% chance, or let's say you can say there's a 5% uncertainty that my loss can be greater than $1 million. So this is what the confidence interval signify. So you need to take either one of it. There can be multiple. You can take 99, 95, or any other confidence interval, whatever you want to take. So with this confidence interval, we try to calculate the Z value. Okay. So basically the Z value is nothing but it is used to determine the threshold below which a certain percentage of the data falls, indicating the level of confidence associated with the VaR estimate. Okay. So basically what I'm trying to say is, so let's say if you are taking confidence interval as 95%, we'll try to calculate the Z value at 5% confidence interval. Okay. So when we calculate the Z value of 5% interval, it will give you a negative number. Okay. So in some of the videos, you'll see, okay, they try to calculate the Z value at 95% confidence interval. So that will give you a positive number. But the magnitude, right? This number, the magnitude will always remain the same. Only the sign will change. So if the sign changes accordingly in the formula, we need to adjust. So if we are let's say if we are taking this Z value at 5%, so in the formula we'll be using plus. But let's say if we are using Z value at 95%, in the formula we'll be using minus. Don't worry, I'll just walk you through the formula. It's we are about to. The next step is about the formula itself. But the important thing with confidence interval is, so whatever confidence interval you are calculating, right? So let's say you are calculating your value at risk at 99% confidence interval. So your Z value will become 100 minus 100% minus 99%, which is nothing but 1%, right? So you'll calculate your Z value at 1%, and this will be a negative number. Or what you can do is you can calculate your Z value at 99% confidence interval. This will give you a positive number. Only thing is the magnitude will remain the same, right? And you just need to adjust the final formula, which I'll be walking you through. But always remember, Z value is used to determine the threshold below which a certain percentage of the data falls. So this is why we require Z value. Okay. Now the final step. Okay. Now let me walk you through the final step, which is the formula for VaR. Okay. Formula for VaR using the variance covariance method. Using the variance covariance method. Okay. So the formula that will use is VaR is equal to portfolio mean return. If you see whatever above steps we have calculated, right? Now we are trying to implement that in a formula. Okay. So portfolio mean return plus portfolio standard deviation times Z value, and this whole multiplied by portfolio value. Okay. This whole multiplied by, okay. This whole multiplied by the portfolio value. Now, above, if you remember, I was saying, right? I mean, if you calculate Z value at 1% confidence interval, so you'll have to use this formula. But if you are calculating Z value at 99% confidence interval, then you'll be using this formula, where is equal to portfolio return. Let's say portfolio return is this. Okay. Portfolio return plus standard deviation of your, okay, here it will change. Yeah. So this is the only place we'll change the sign. So if you see here, we were using plus. If you see here, we are using minus. So standard deviation of your portfolio times Z value, and this whole multiplied by portfolio value. So when I say portfolio value, I mean, okay, what is the value of investment that you want to do? Is it $1 million or whatever amount, right? So this is the formula that you have to use to calculate the value at risk. So if you see now above steps, what we did was we first calculated the portfolio return, then we calculated the standard deviation, then we calculated the Z value, and that's how we can basically calculate the value at risk using the variance covariance method. So this was all about this method. Let me walk you through the Excel implementation of value at risk. So let's start the Excel implementation of value at risk using the variance covariance method. So basically, as I said, the very first step is to download the data. So I have taken three stocks, which is JP Morgan, Morgan Stanley, and Bank of America. So if you see, I have taken the stock prices uh, from 2022, August 2022 to August of 2023. And how to get this data is you can basically have also added the instruction, which is basically visit the Yahoo Finance website, search for the stock that you are looking for. So let's say I've taken JP Morgan, Morgan Stanley, and Bank of America. So you need to search for your stock. Then you should select the stock. There will be a tab which says access historical data. Then you should set the range, choose frequency. So what we are taking is a daily frequency data, and then download the data. So when you download the data, right, you'll receive something like this: JP Morgan, Morgan Stanley, Bank of America, right? So once you download the data, just take in adjusted close price. Right. So if you see, I've taken the adjusted close price for JP Morgan, Morgan Stanley, and Bank of America. Okay. So this is, as I said, this was our first step, which was to download the data. So as soon as you download the data, as we know, the second step is to calculate the value at risk. So basically, as I said, this was our first step, which was to download the data. So as soon as you download the data, just take in adjusted close price. Right. So if you see, I've taken the adjusted close price for JP Morgan, Morgan Stanley, and Bank of America. Okay. So this is, as I said, this was our first step, which was to download the data. to basically calculate the stock returns, right? So if you remember how we calculate the stock returns was, so this was price today, this was price yesterday minus 1, right? So we'll just use this minus 1 and we'll just add the bracket. So this is the formula that we'll use. Then what we need to do is we need to press shift and the right key and the right arrow key and press Control R. So this will automatically populate the formula. Okay, so if you see Bank of America, it is automatically trying to calculate the return. And the next step is just what do you have to do is press Control. Wherever your data ends, just write anything, any value, right? So just so what you need to do next is press Control Shift down key. So this will go till the down, right? And then press Control D. So just this will automatically populate your returns, and then just do okay. Then just do shift and right arrow key, and just put Control R. So this will basically automatically populate your daily returns. Also remember this thing, right? If you see the data is starting from 8/1/2022, whereas I have taken the returns from 8/2/2022. So whenever you try to calculate your returns, it is from this, right? I mean, you'll always have one missing value, which is fine because it is the way the formula is set up. So basically, if you want to calculate your return as of 8/2/2022, you need to take his today's price divided by yesterday's price and subtract by 1. So that's how we calculate the return. Um, I've also added, basically the reasoning, why we take returns and why we have not taken the stock prices. As I said, if there's a $5 increase in a $10 stock, it is a 50% return, whereas a $5 increase in $100 stock, it is really, I mean, a $5 increase in $100 stock is less. So, we always should make sure, like, we always consider when we speak about it, we should always take return when we talk about it. And similarly, the second reason why we take return is stock prices are non-stationary, and that's why we need to make our time series stationary so that the statistical properties remain same over time. And that is one of the main thing when you do modeling, right? So as I said, you compute the daily return. The third thing that we do is the third step is basically we need to calculate the portfolio mean return, right? Or let's say the portfolio return, right? So if you see, we have assigned weights, which is 30%, 40%, and 30%. So we are assigning 30% into JP Morgan, 40% into Morgan Stanley, and 30% into Bank of America. So assuming like we have an investment amount of $1 million. So, this is nothing but we are just multiplying 30% with $1 million to arrive at our, what is the stock value, or let's say what is the price that we are trying to purchase for JP Morgan. So, which is $300,000 for JP Morgan, $400,000 for Morgan Stanley, and again $300,000 for Bank of America. So, these are some assumptions that we take, basically on the weights of individual stocks. Now to basically calculate the return, as I said, to calculate the daily return, it is nothing but the addition of W1 R1 plus W2 R2 plus W3 R3, right? So if you see, what I've done is I've just done a sum product, which is nothing but first it will do the product of individual stocks with the weights, that is, sorry, individual returns with the weight, that is W1 R1, W2 R2, W3 R3, and then it will sum it up. So that is why we can use a sum product function to calculate the portfolio return for every day, and then you just need to drag this formula till the end so that we can basically get a daily portfolio return. So as I said, now since we have already got the daily portfolio return, we just need to average the returns to calculate the portfolio mean return, right? Because if you see, this was just the daily return, but we need to have a portfolio mean return. So that's how we just need to average it out, and that's how we'll get the portfolio mean return. Also, what I've done here is I've just basically calculated the individual returns of the stock of individual returns of the stocks, and then I've taken the weights and I've just done a sum product. So it's a it's a similar way, but you can use any one of them. Either you can first calculate the individual returns, multiply them with the weights, and then add them all, what you can do is basically the method that I showed. It's both the same. It's just that in this method we are directly multiplying all the weights with the returns. So once you take the average of it, we have got the portfolio mean return. Also I've just added the formula for portfolio mean return. The next step is nothing but to calculate the portfolio standard deviation. So as I said, most of the freshers, what they try to do is they just take the weights and they just multiply with the standard. If you see, what I've taken is the standard deviation. So they just multiply the standard deviation, and they come up with this value. Yeah, okay, sorry. So yeah, so they what I've done is just taken the variance.s, which basically calculates the variance of the sample, and then just take the square root of the variance to arrive at standard deviation, right? And then do the sum product. So as I said, as I covered in my video, that this is basically a wrong way of calculating the portfolio standard deviation. So, and I also showed you what is the right way, that is basically calculating the covariance matrix and then multiplying it with the weights of the weights of the stocks in the portfolio, because the covariance matrix also captures the correlation, which this method, right, with this method does not captures, right? So let's understand how can we calculate the covariance matrix, right? So I've just added this formula, of step by step how to calculate the covariance matrix. But let me show you. So we'll go in data. Then on the right hand side you will see data analysis. So in the data analysis, as you will click, you will see covariance. So when you click on covariance, you just put OK. Select the input range. So we'll just select our returns. Okay. And then I want my output into this this current sheet, right? I just want my output in this current sheet. So let's say I want my output here. So I'll just press OK. Okay. So this is how I'll get the standard deviation. Basically, I'll get my covariance matrix. So what I need to do, I just need to instead of having column 1, 2, 3, I just need to add my, basically the names of the stock. I just need to replace it. And now if you see these columns, these rows are empty, right? So how to fill it? Now this is basically the covariance between Morgan Stanley and JP Morgan, right? So if you see, the covariance between Morgan Stanley and JP Morgan is here also, right? So we just need to capture this. Similarly, this is the covariance between Bank of America and JP Morgan, and this is also the covariance between Bank of America and JP Morgan, right? So you just need to fill it here. Similarly, this is what the basically the covariance between Morgan Stanley and Bank of America. So if you see here, the covariance between Morgan Stanley and Bank of America is this. So like this, basically, you can fill in the covariance matrix. So this is what I have done here. So it will be like, so this will be the covariance matrix. Okay. So I'm just removing this because this is nothing but it's the same. So after doing this, right, what is the next step? As I said, we need to multiply the weights, right? If you remember, so what I'm doing is, in Excel, we have a thing called matrix multiplication. So what we do is we first do a matrix multiplication of, of basically so let's see, what is it? Basically we are multiplying our weights, which is BJ6 to BL6, with our covariance matrix, right? So after we matrix multiply that, after we do a matrix multiplication of this, again multiply this with the transpose of the weight. So whatever result you will get using this, just do again a matrix multiplication with the transpose of the weights, right? So this will give you nothing but the variance of your portfolio. This formula will give you the variance of the portfolio. And as we know, to calculate the standard deviation of the portfolio, we just need to take the square root of your variance, right? So that's why in the end I've just placed in the square root. So this whole formula captures the standard deviation of the portfolio. Okay. So I've just written, what is wrong in this method, which is basically nothing but it ignores the correlation. And if you see, the covariance matrix captures the correlation. So now let's this is which is like the final step of calculating the value at risk. So now we have the portfolio mean, we have the portfolio standard deviation. Let's say we are calculating at 99% confidence interval. So the if our certainty is 99%, our alpha becomes 1%, which is nothing but 100% minus 99%, or you can also say 1 minus 99%. So that's how you will calculate your alpha. And as I said, you'll basically calculate the Z value at this 1%. So to calculate the Z value, we have a very straight formula in Excel, which is norm.s.inverse. So this will help you to calculate the Z value at 1% confidence interval. And we are assuming that, okay, we have a portfolio of $1 million. So we are now just using our formula, which is nothing but mean plus z score times standard deviation, and this whole multiplied by the portfolio value. So similarly, if you see, if we take any other confidence interval, right? So you will see, okay, let's take the returns and the standard deviation. Any method, any confidence interval you calculate, right, it will remain the same, right? So let's say at 95% confidence interval, your alpha will become 5%. So you need to calculate your z value at this 5% alpha, and then we'll use the same formula, which is mean plus z value times standard deviation, and this whole multiplied with the portfolio value. Similarly, the mean and return will remain the mean and standard deviation will remain the same, assuming a 90% confidence interval. So your alpha will become 10%. So once your alpha is 10%, you need to calculate the z value at this 10%, and then use the same formula that we spoke about. So, you will see like all these numbers are negative, and the main reason why these numbers are negative is because it's a loss in our portfolio, right? And when we report losses, it's always negative. So, or sometimes what people do is they just they just report it like this. Okay, let me show you. So they'll just report it. They'll basically take the subtraction of this, and they'll just report it in a positive way, because everyone knows, okay, that value at risk is a negative, is a loss, right? So since everyone knows it, you can also report it like this, or you can use this format also. So basically you will see one thing, right? As the confidence interval is decreasing, the loss amount is also decreasing. And this is a very important thing to note, because as we loosen, as we go, as we take in the 90% confidence interval, it will happen that, uh, like the losses will be lesser. So how do we analyze this number? How to interpret this number? So basically it means the value at risk value of $35,609 represents that it is the maximum loss that can happen in your portfolio during a single day under a normal market conditions. Okay. So what we are saying is, we the 19 we the 1 day VaR, okay, the 1 day value at risk, because it's a 1 day value at risk, right? So the 1 day value at risk at 99% confidence interval is $35,609, and this is the maximum potential loss that can happen over a period of 1 day. So this was all about the variance covariance method, and I hope you understand. How do we compute the variance covariance method? It is very straightforward. First is we gather the data. Second step is to calculate the return. Third step is to calculate the portfolio mean return. Fourth step is to calculate the portfolio standard deviation. Then fifth step is nothing but taking into consideration the confidence interval and the time frame. So time frame is 1 day, 10 days, something like that, right? And then last step is using this formula, which is 1 day value at risk. Also remember here, we are adding plus because we are calculating Z value at 1% confidence interval or 5% confidence interval. So if in case we are calculating Z value at 99% confidence interval, so this will become minus. Okay. It's just this change in formula, which is like, depending on what Z value you are considering. And also I covered this in our theoretical part, that why we are doing Z value, because Z value at 1% is a negative number, whereas Z value at 99% is a positive number. So this was all about how do we calculate the value at risk using the variance covariance method. Thank you all. In our next video, we'll be understanding how to calculate value at risk using historical simulation method. Thank you.